All right, so we're just going to do more of the graphing that we did yesterday. Same basic idea. But kind of talk through the concepts here. What? I think you'll think it's easier because we've done it. So this is mostly just a review of what we already did. All right, here we go. Example 1. We are going to graph the volume of water in a glass as you drink it, okay? So my question, first of all, is what do you think your two variables should be here?
Volume of water and
Volume. We're going to put the volume here. And what else?
water.
I heard it from someone. Time.
Yes.
Okay, as you drink, right? Over time is basically what they're saying there. So the volume of water in a glass as you drink. Now, they don't tell you what the volume started as, but that's okay because this is all relative. We're not putting numbers in for our volume. So let's just say we're going to start here with our volume of water. Okay? Now, depending on how you drink a glass of water, your graph might look very different than the person's next to you. For instance, my graph would look like this. No, my graph would, well, sure. My graph would look something like that. My husband's graph, I'm not going to label this. My husband's graph would look something like this. What's the difference? He doesn't stop, right? He just like drinks the whole glass of water. Like, I'm thirsty, I'm going to drink a glass of water. Whereas I mean, if you see me throughout class period, I don't even know where everything is. Oh, it's over there. I drink a little bit, and then I set it down, and then I come back to it, and I drink a little more, and then I set it down, right? So what's happening in mine is take a drink, and then stop for any period of time drinking, then take another drink, stop drinking again, take another drink, take a little break again, take another drink, and I'm done. Okay? Whereas my husband would just drink the whole glass. Okay?
I would stop.
You like stop? Yeah. Questions on that? Okay. So that's the first one. Second one.
So like they'll drink the whole entire thing in one.
Well, see, it probably wasn't that big. If it was that big, he would take. I'm thinking like a glass. Like if we fill up a glass at dinner,
I'd still.
I drink a little bit at a time. He just drinks the whole thing.
But when I have like iced tea, I drink it all in one.
Really? That's
Yes.
so sweet.
It's not okay. No, like I'm saying.
Oh, gotcha. Do you ever get the sweet tea from Chick-fil-A?
Yes, it's bomb.
I love it. Okay, so we're going to graph the distance from home. Here's what it says. Walk to the bus stop. Wait at the bus stop.
Is this one hard to make the graph?
Uh-huh.
This is so hard.
Ride the bus to school. Arrive at school. Okay, so these are the pieces. Weight is horizontal, yep. this is what you're gonna do, okay? First of all, it told you what to graph. It says graph the distance from home. So we're gonna put the distance from home as our variable over here. What do you think our x-axis? Time. Most of the time, it's time. Not every time, but a lot of the time. Okay, so we're talking distance from home. How far are you from home when you start your day? You're at home, right? So we're starting down here at 0 because we are at home to start our day. So when we walk to the bus stop, now think about this. You're walking to the bus stop, you're riding a bus to school. Which one of those is going to be a steeper slope? Riding to school, right? Because you ride faster. So time is less when you're riding versus when you're walking in terms of distance. Okay, so if we are going a walk to the bus stop, that would probably be on less of a slope, right? Something like that. So that would be our first little chunk here. And then, like Olivia said, when we wait, that's going to be a horizontal line because time is increasing, but your distance from home is not. Okay, so this wait is this piece. Okay. Then when we ride the bus to school, what happens to that next line?
Goes up.
How does it go up? Steep, right? Because when we were walking, that was less steep. So if we're riding the bus, we're going to go steeper like this. Okay, ride the bus to school would be here. And then arrive at school. When you're at school, you're the same distance from home pretty much the whole time, right? So arriving at school would put you here again. You're at school. You're staying in one spot. Does that make sense? Okay. You could do the end of your day too then. You ride your bus back home. This time you don't have to wait. You can just walk back home. So if you wanted to go that far, you could do something like that too. That wasn't part of the problem, so you don't have to do that part, but if you were to do it, that's what it would look like. Okay, question for you. I'm going to give you a graph. You tell me what you think the variables might be here. So let's say we have this. And our graph looks like that. Okay, so I want to know what you think might go here and here. Or tell me, maybe if you can't come up with that quite yet, tell me what you think might be happening in that graph. What? You could be jumping. Yeah. Someone could be jumping. What's happening with their jumps?
It's going down, up,
The height of their jump is doing what each time?
it's
Decreasing. Their height is getting lower every time of their jump. Okay? I thought of something else. Anyone else think of a different thing that could be happening here? What? Oh, you could do a trampoline. Yeah, jumping on a trampoline.
Maybe like that ball.
That's what I think of because I got kids with bouncy balls all over my house. So if you were to drop a bouncy ball, right? The reason I think bouncy ball is it starts high. Okay, so if you were gonna do a jump, like at my house, so I have a trampoline in my backyard, and then we have this little like tree house. So you can start on the tree house and jump off onto the trampoline. So that would work here. But if you're jumping from the ground, this graph doesn't work. Okay? So because we start up in the tree house, then jumping could be a thing. Or maybe you jump from, the roof and then keep jumping. I don't know. Something like this. But this would be like the height of whatever, a person's jump or the height of a ball, if we're doing the ball one, over some amount of time. So the bounces are getting smaller, smaller, smaller until eventually the ball is rolling on the ground, right? Does that make sense?
Yes.
Okay. That's what we're doing for today.